Hello, fellow Geospatial Systems I 1470 students. This is our application paper presentation over a peer-reviewed article we found pertaining to GIS. This presentation is brought to you by Vanessa Navarro, Grace Rush, and Madison Mahar.
The article is titled A GIS Approach to Mapping Oil Spills in a Marine Environment and was written by U. Ivanov and V. Zatyagalova. Why is this article important? This article is important because it introduces the use of additional technology such as GIS to further advance oil spill identification and management in the ocean. What question was the author trying to address or resolve? The study was intended to prove how using SAR alone is not as effective as using it alongside GIS when identifying oil spills in the marine environment. Why did you choose it? We all had similar interests in researching a study that confronts man-made environmental issues.
Now we're going to get into addressing the problem that the article focuses on. So from the article, we found out that it is estimated there have been 10,000 oil spills from the years 1970 to all the way to 2001. We also found out that small oil spills are usually unaccounted for and are therefore uncontrolled. So that's the main focus of this article. So researchers wanted to address the lack of oil spill data and wanted to figure out how to better manage it. They also wanted to see how they could improve oil spill knowledge with GIS and SAR technology, which we're about to get into what SAR is, to have an easier way to analyze oil spill areas. So obviously because oil spills go unaccounted for and people aren't held responsible, this poses an issue because habitats and marine life are being affected by these spills, as you can see in the image to the right. So one of the main goals of these researchers was to see how effective and helpful it was to incorporate GIS and SAR technology to contain oil spill data.
Now for the advantages and disadvantages of SAR. Spaceborne synthetic aperture radar provides a wide area coverage by using satellites and allows for real-time images to be taken. However, because SAR relies on the sea surface roughness, this creates many limitations. For example, oil spills can be mistakenly detected as dark patches. Some examples include natural slicks, such as biogenic films, and lookalikes, such as low wind areas, rain cells and algal blooms, and man-made oil spills. To combat the issues with SAR, there needs to be a better analysis of slick appearance, environmental conditions, and contextual information relative to the area, as well as other concurrent oceanic and atmospheric phenomena. This is where GIS comes in.
What does GIS have that SAR doesn't? Well, GIS allows for more data sets to be added to the map, and by using different data sets such as those listed to the right, researchers and protection agencies can accurately map and identify oil spills and their sources. SAR imaging does not allow for additional data sets to be added, and it can only create 2D and 3D images.
Now we're going to look at how GIS has the potential to solve this problem, or what the researchers of this study saw in GIS, why they think it should have been incorporated into this study. So first off, by using data compiled from several sources, GIS is able to create oil spill distribution maps, much like the one you can see to the right. That's a good example. This data can be compiled from different sources such as nautical maps, geodatabases, and remote sensing data. Much like what we see in our ArcGIS labs, how there's a lot of different data all incorporated into one map, and you can kind of manipulate what you see and don't see. Second of all, these maps will allow for the retrieval of key information such as the prediction of oil spill locations. That was kind of their main focus, but not only that, these maps can also show key information such as reveal offshore and onshore sources of oil spills, and even estimate the intensity of the pollution, meaning that it can again incorporate different pieces of data such as pollution in the area or where this oil is coming from. Third, this solves the problem of unnoticed, unmanaged oil spill pollution in the marine environment because oil spill distribution maps can prove useful for decision makers and environmental agencies. So it's awesome because GIS can allow for the ability to extract oil spill parameters such as location, linear size, and even the spill area. It also allows for the identification and categorization of additional information, which can then be arranged and used in GIS, again, like I was saying, much like ArcGIS. GIS is also able to quantitatively and qualitatively characterize environmental conditions and the spatial and temporal distribution of marine basins as a whole.
In these project sites, oil pollution from various locations such as fishing operations, oil production, and river runoff were sought out and observed. In the Japanese Sea, the GIS approach successfully pointed out areas with linkages between oil spills and surrounding areas, which ultimately gave insight to where some of the oil spills and leaks originated from. Within the Caspian Sea, technology allowed users to collect various kinds of data and information which ultimately allowed them to estimate locations of oil seepage on the sea floor. The Black Sea oil spill distribution maps allowed for individuals to determine the primary source of oil pollution, a tanker fleet traversing the northeastern part of the sea. Later within the observations, it was discovered that the large detections of oil originated from a port. To confirm this, a helicopter flew over the area of observation. With the help of GIS, the Gulf of Thailand site allowed for accurate maps to show the distribution of oil spills and risk within the area.
Oil spills in the Black Sea. As discussed in the journal article, the figure to the right illustrates the use of SAR imagery and GIS to map tanker pollution of project site number 3 in the northeastern region of the Black Sea.
So now we're going to talk about some of the results that came out of this study in this article. Many things were concluded from this, but these are some of the main takeaways that we found most interesting. So first off, we found that, or the study found out, that the use of this geoinformation approach is an efficient base for oil spill monitoring, but additional information should always be incorporated. Meaning that this GIS mixed with SAR approach is pretty efficient and for the most part accurate, so it's a good base to start with when doing research on oil spills or pollution for that matter in the ocean, but additional information should be incorporated, such as maybe an analysis of what the shoreline looks from observations in the certain area itself and things like that. Secondly, it was concluded that GIS can qualitatively and quantitatively characterize oil spill distribution and environmental conditions. So this is basically saying that GIS is efficient and incorporated multiple data features in the sea basins as a whole. And also different databases can be analyzed, such as seawater quality, nutrient and chemical compositions, and things like that. So this meaning that lots of other good information can be observed and incorporated into oil spill maps through things like GIS and SAR combined together. And lastly, this GIS approach provides expansive resources for managers and technical personnel for decision making regarding oil spill distribution and environmental consequences. So this is again a good base of knowledge that multiple leaders and decision makers can use in order to be more efficient, as well as take less time in making decisions or looking at what's going on in the ocean at the time, so that people don't have to for instance, go up in a helicopter and look at an oil spill themselves. They can look at the GIS and SAR data available in things like oil spill maps. It is also efficient in, again, like I was saying, showing the data. But what I was going to say is that it's important to always keep this information updated. So if you do have an oil spill map that is made, it should be routinely updated again, so it is completely accurate. And that could also go along with incorporating more information. So altogether, researchers were just looking to see how this GIS approach would be beneficial to oil spill concerns for the 4 studied areas. They also found that this approach of managing oil spills provides a new functionality and vision to the problem. So a GIS project in the Caspian Sea has already been started because of this project. As you can see to the right, that is a picture of the Caspian Sea. So again, results from this are expansive and various, but basically saying that GIS is a good source of base knowledge for oil spill maps.
Now for the discussion. This journal article was published in 2004 and provides a valuable introductory approach to GIS regarding oil spills that have the potential to be very efficient for researchers and decision makers. GIS is useful because researchers are able to continuously add new and updated datasets and sources allowing for the creation of more accurate oil spill distribution maps. And finally, the conclusion. GIS has proven to be useful in oil spill mapping because the system allows for the integration of information from a variety of different sources, which can then be used to display information as a whole, resulting in planning and response to the pollution, as you can see in Figure 4 to the left.
And lastly, here are our resources. So what you can see right there first is a citation for the peer-reviewed journal article we used, as well as the URL with it. And under that are the figures we've used in this PowerPoint cited. Thank you.